Okay, everyone, welcome back to Global Kids Connect Mathematics. Today we'll be covering the topic of graphs. Uh, we covered a little bit of graphs in our previous class at the very end. However, today we'll be going into a bit more detail regarding different types of graph problems and how to solve them. And so the first concept of today is understanding graph basics. And so the definition of a graph is a graph represents a function f of x on the xy plane, showing the relationship between x values, also known as the input values, and the y values, which are known as the output values. And key features include intercepts, roots, where the f of x or the y value equals to 0, as well as the shape of the curve. And so a couple key skills are identifying the x-intercepts, also known as the roots, the y-intercept, and the general shape of the graph. And so we'll move on to our first example question, a simple one. The problem states, what is the sum of the x and y-intercept values from the following function on the xy plane? And so we need to find two kinds of intercepts, the x and the y. So the x-intercepts, as talked about in the problem, represent when the graph itself touches the x-axis. And so the x-axis is this horizontal line here. And so wherever this graph touches with the x-axis will be the x-intercept. And here we can see that that point is here when x is equal to 5. And so we can say that our x-intercept is equal to 5. And now we also need to find the y-intercept. And so the y-intercept is when the graph touches the y-axis. And so that happens at this point right here, which the y value for is 8. And therefore, we can say that the y-intercept has a value of 8. Knowing these two, the question asks to sum them, which means adding up the two values. And so the sum of the x and y intercept will be 5 plus 8, which equals 13. Fairly simple, but does anybody have any questions regarding this one? If not, then we can move on. This was kind of a warm-up, pretty simple. And so the solution is, as I explained, and then a couple of tips is for find the intercepts, make sure to remember that when finding x-intercepts, set the y value as 0. And so, for example, the y is 0 at any of these points right here. And we can see that the graph has a y value of 0 when it has a x value of 5, which represents the x-intercept. And then the opposite is true for finding the y-intercept. You have to set the x value equal to 0. And when you set the x value equal to 0, it represents this line here, this vertical line. And then the graph passes this line when the y value is at 8, which represents the y-intercept. And then always check both separately before combining. Pretty simple. And so now that we got our basic understanding, we can move on to a couple more details. And so our next concept is roots and double roots. And so roots are x values where the y is equal to 0, and a double root occurs when the graph touches the x-axis and turns. For example, at the vertex of a parabola. So some of you might be a bit confused, but if we draw a graph, any graph, let's say we have a graph that goes like this. Oh, like this. Uh, from here, we can say that the graph has roots where y is 0, right? And so we just have to find any points where the graph touches the x-axis, which is when the y value is equal to 0, which are these 2 points, for example. And so we can say that these two are both roots. However, sometimes a question asks for a double root. And so a double root, as shown in the definition, is where the graph touches the x-axis and turns. So what does it mean by turn? It means that for if you look at the left side of this example graph, you can see that the graph does touch the x-axis, meaning it is a root. However, it doesn't go through it. It doesn't go past, but rather it goes back and away from the x-axis again. And so points where this kind of phenomena occur, we call a double root. And so this is both a root and as well as a double root. So a couple key skills for any problems utilizing this concept is to locate roots on the graph and to determine if a root is double by observing the graph's behavior. So which way the graph turns and the shape of the graph. Anybody have any questions for the concept? If not, then we can move on. And so we have our example question here. And so the function fx has a double root at x equals a. What is the value of a? And so, like we did before, very simple. So we're trying to find a double root, and it says there's a double root at at a point where the x value is equal to a. And so if we just take a look at the graph itself, we can see that there are 2 points where there are roots. And then out of the two, only one of them have a double root, which is the left side point, because the graph touches the x-axis, but then it turns away. And so this point will be our double root. And yes, as Sarika said, the value of a will be -4, because if we look at it here, we can see that it touches at a point where x is equal to -4. And therefore, our a value is also -4. Any questions for this one? Okay, then we're going to quickly move on. And so solution, very simple. And a tip for these kind of questions is to, when the curve bounces off the x-axis, instead of crossing, that x value is a double root. And so you should always look for the what I call the touch and turn. So when the graph touches the x-axis and then turns away. We can move on to our next concept. So the graphs in general have a lot of different concepts. So we'll be focused. There'll be a lot of concepts that we'll be going through. I will go through each of them again at the end. So fear not. And so our third concept is slope and its interpretation. So we covered a bit of slope in previous classes, especially in linear equations, but then we'll go through them again just to remember. So the definition is slope measures the steepness of a line calculated as the change in y over the change in x. And for example, if we have a linear equation like this, the slope is the value of m. A couple key skills is to determine the slope from a graph by finding the ratio of vertical to horizontal change. And so always remember the slope equation, which is equal to the change in y over the change in x. And so I think we can move on to our example question. And so from the function fx on the xy plane, what is the slope of the function parallel to fx? And so the question asks for a slope of a function parallel to fx. However, that just basically means find the slope of fx itself. And therefore, when you're given a graph instead of numerical points, then it's important you choose the correct points to use for finding your slope. And so I recommend points where it touches exactly a cross line, like here. And so one of those points will be this point, because we can see that we are able to find the x value as well as the y value for the point. And so it's a good point to utilize. And then the second point we can use, I usually recommend, is a point when the x value is equal to 0. As most of the time, the graphs given in the digital SAT do have a usable point when the x value is equal to 0. And so using these 2 points, we can actually find the slope itself. And therefore, we can find it by saying that our first point is -5, comma 2, and our second point is 0, comma 5. And like I said, using our slope equation, the change in y over the change in x, we can write down if these are the value of x2, y2, excuse me, and then x1 here, y1 here, we can write 5 minus 2 over 0 minus -5. This, when simplified, is 3 over 5. And therefore, we can say that our slope is 3 over 5. Oh, this one. The solution is the same. And then a tip is to always pick two clear points on the line. Read their coordinates precisely, their x and y values, and then use the slope equation, the change in y over change in x, in order to find the slope itself. Does anybody have any questions for this one? If not,
Not any questions, sir.
okay, thank you. Then we can move on. Our next concept is intercepts and specific function values. So until now, it was pretty basic. From here, the concepts are much more useful regarding their ability to solve digital SAT questions. So let's take a look at them. The definition is the y-intercept is where x is equal to 0, and the x-intercept is where y is equal to y is equal to 0. Function values like f of -a or f of b can be read from the graph. So what this means is that if we are given a graph like before, let's say this kind of graph, and it is said that this graph is written as f of x, then what this means is that if there is a point here, uh, or let's say there's a point here where the x value is equal to -a, then we can say that the function, the graph function, where the x is equal to a, so we can write f of -a is equal to the y value at that point. And therefore, here we chose the intercept or a root, and therefore the y value will be 0. And so this shows that we can write in forms of such with f and a parentheses to write usually the y values of certain points. Therefore, key skills is to find intercepts and evaluate fx at specific points using the graph. So it's a lot about analyzing the graph itself. Anybody have questions for this one before we move on to our practice question? If not, then we can move on. And so our practice problem says, what is the product of f of -6 and f of 6 from the function on the xy plane? And therefore, like I explained, when we are given a function of f of x, and then we have to find the values of f of -6 and f of 6. And so remember that these values are the x values. So we can say that this one is x1, this one is x2. And therefore, and the total expression f of something represents the y value at that x point. And therefore, we can first try to find the value of f of -6. Therefore, we find a point where the x value is -6, which is here. And then f of -6 asks for the y value at that point. And therefore, we draw a line until it touches the graph itself. And then from here, we can see that the line is at -2. And therefore, f of -6 is equal to -2. And then the function of f of 6, like we did for -6, we find where x is 6, which is this point, go all the way up until we touch the graph, and then check the y value at that point, which is 5. And therefore, f of 6 will equal 5. And then the question asks for the product of these two values. Product meaning the multiplication of two values. And so the product, we can say, is equal to -2 times 5, which equals to -10. Does anybody have any questions for this problem? If not, then I think we can move on. And so the solution is the same, and then I didn't put in a tip for this one because it's pretty straightforward on what you have to do. Uh, if I have to think of one right now, then I would say that to always uh, make sure because on the digital SAT, because it is digital, you cannot draw directly on your device. And so make sure to correctly analyze and locate the point and the y values at which you are interested in and you have to find. Because I know that it is pretty difficult when analyzing graphs, especially looking at points that's far away from the axis, like this point here. Sometimes you might mistakenly read -4 when the actual value is -5. And so just be careful regarding that. And then I think you'll be able to get most of every question related to intercepts and specific values pretty well. And so we can move on to our next concept. I believe this is our final concept. And so we are learning about perpendicular lines and function interactions. And so what this means is that two lines are perpendicular if their slopes' product is -1. We did cover this in our, I believe, linear equations class couple last week. But it's good to always go through it again to refresh our memory. And then we can also there's also functions can intersect or be related through intercepts or values. So we'll take a more detailed look when we're analyzing the example problem. And so a key skill for these kind of problems is to determine the equation of a perpendicular line and analyze function relationships. And so this concept is better understood when we take a look at an example problem. So we'll do that now. So our example problem states the function f of x is perpendicular to g of x, where g of x crosses the y-axis at 0, 8, which is the correct expression for g of x. And so we're given a graph that shows the graph of the function f of x. However, we don't know what g of x is, and we have to find the expression and the equation for it, utilizing the information given to us. And so we'll do that now. The first piece of information is that fx is perpendicular to g of x. We learned that if the product of two slopes is equal to -1, then those two slopes are perpendicular to each other. And so we will be able to utilize that. And so, and the second piece of information is that gx crosses the y-axis at 0, 8. So using these two information, we can find the equation for g of x. So using the first piece of information, the two slopes being perpendicular, we can find the slope of gx. But then, first of all, in order to do that, we have to find the slope of the function f of x. And so we'll try to find that. The slope of f of x is equal to, uh, remember, like we did for our previous concept and our previous example problem, we have to pick 2 points where we can find the direct x and y values in order to evaluate our slope. And so, as always, first point, if possible, utilize the point where x is equal to 0, which is this point here. And then a second point you have to choose after analyzing the graph. I think I would choose the point right here. Uh, yes, and so using these 2 points, we have points 0, 2, as well as 2, 3. And so using the slope equation, like we did, change in y over change in x, we can say that the slope is equal to 3 minus 2 over 2 minus 0, which is equal to 1 over 2. And so now we know that the slope of f of x is equal to 1 over 2. If we know this, then we can also know the slope of g of x, which in the problem says is perpendicular. And therefore, uh, you can either use the product equaling -1 or finding the negative reciprocal of our first slope. If we find the negative reciprocal, negative saying meaning that is the opposite sign, and reciprocal being the 2. And so we can also prove this using these perpendicular theory equation where two slopes, when multiplied, are equal to -1. And so we prove that these two slopes are perpendicular and that the slope of gx is indeed -2. So we know our first piece of part of the gx equation. Now we have to find the uh, the y-intercept of the gx equation. And therefore, the problem states gx crosses the y-axis at 0, 8. So this means that if we have a gx function, we know that the slope is -2, and so it will be sloping downwards like this. However, the problem also says that when the x value is 0, the graph value of g of x is equal to 8. The y-intercept is 8, and therefore we can write the function of g of x as a linear equation because it is a linear graph. We can say that the slope is -2, and so the coefficient in front of x will be -2. And because the y-intercept is 8, we just add a +8 at the end. And therefore, this will be our final answer and equation. Does anybody have any questions regarding this problem?
No, sir.
Okay. Uh, if not, then I think we can move on. And so solution is the same for the tip. Uh, to find a perpendicular slope, take the negative reciprocal like we did. If one slope is m, the other will be -1 over m. So make sure to remember that. Or you can also use the equation m1 times m2, two different slopes. The product of them will equal -1. And so before we move on to our challenge question, does anybody have any questions regarding any of the concepts we covered until now before we move on? I don't think so. Okay, then I think we can go directly into our challenge questions for today. And therefore, our first challenge question is if f of x is equal to 5x minus 8 and g of x is equal to 2x squared minus 5x minus 9, what is the product between the x-intercept of f of x and the y-intercept of g of x? So the problem itself is a bit confusing because there's multiple equations and then different values we have to find for each one. However, so we get two equations, f of x and g of x. And for f of x, we have to find the x-intercept. And for g of x, we have to find the y-intercept. Okay, and so there are multiple ways to do this. First of all, we look at it algebraically using equations. And so we can say for f of x, if that is equal to 5x minus 8, then we have to find the x-intercept. And so if you remember, the x-intercept is when a graph, for example, this kind of graph, touches the x-axis, which is also when the y value is equal to 0. And so for the function f of x, we'll set the y value as 0. And so 0 will equal 5x minus 8. So we can move this around. 5x will equal just 8. And then x will equal 8 over 5. And then we'll find for the g of x, 2x squared minus 5x minus 9. We can say that the y-intercept for this, so the y-intercept is when the x value is equal to 0. And therefore, we'll set, so g when x is 0 is equal to 2 of 0 squared minus 5 times 0 minus 9. And therefore, because we multiply it by 0, these two terms will be equal to 0, and so we can cross them out. The only thing left will be negative 9. And if we know the x-intercept and now the y-intercept, the question asks for the product between those two values. And therefore, we can multiply 8 over 5 times negative 9, which is equal to negative 8 times 9 is 72 over 5. And so this will be our final answer. And then one more thing before, just to note, for the digital SAT math section, some questions, there are questions that are not multiple choice, but rather questions where you have to put in a numerical value for your answer. Most of the time, you can write them down as either fractions, like in this case, or as well as in decimals. So in decimals, this would be negative 14.4. My recommendation is that because some fractions don't have a, uh, I guess, finite value for the decimal expression, I do recommend most of the time to write the fraction form of your final answer. And so, yeah, that's the only thing to know for this. And then, does anybody have any questions regarding this problem? Okay, if not, right before we move on to our next question, we can actually see that there is another way to solve this problem instead of algebraically. So if you're comfortable using just basic mathematics and algebraic equations, you can solve it in this way. Or if you say, for example, that you think this method will take a bit too much time and then you're not fully comfortable with it, then you can actually utilize the Desmos calculator to solve this question as well. And so if you open up Desmos calculator, you'll see that there is at the top a screen where you get the XY axes and areas to put in your equations. And so you can actually plug in f of x and g of x into the Desmos calculator itself. So you can write down that instead of f of x, we will write down the variable y so that we can draw a linear equation. So y will equal 5x minus 8. And we can also put in the function for g of x like such. And after doing this, the graph itself, the Desmos calculator will graph the functions for you. So for example, f of x will be something like this, where the x-intercept is here. And then g of x will be a function such as, uh, not sure the exact shape, but then it will be something along the lines of here. And the y-intercept will be here. And so when you draw the equations within your Desmos calculator, if you get your mouse cursor and put it over any intercepting points with the x and y axes, it will actually give you information on the point itself where it intersects. And so for f of x, which was this linear equation, it will show you the x-intercept, 8 over 5 comma 0. And for g of x, it will show you as well the y-intercept. So 0 comma negative 9, which is not correct for this graph. I'll redraw it. One moment. So it'll be something like this. Ooh, let's say it's like here. Then this point, it'll give you at 0 comma negative 9. And so using the Desmos calculator, you can actually probably solve this question quicker than the algebraic method. And so, whichever is more comfortable for you, and then which one you think you'll make the least amount of mistakes, I recommend choosing when solving these kind of questions within your digital SAT math. Anybody have any questions for this before we move on?
No, sir.
Okay, then we can move on to our next question. And so our next challenge question asks, if f of b is equal to g of b plus 2, and b is an integer, what is the value of 2b given the graphs? And so we can see that uh, it gives us two pieces of information. First, a relationship between the two equations, as well as b being an integer. And we have to find eventually 2b. And so if we first look at this right here, we can see that it says a point where the x value is equal to b. So a point where x is b, and we have a certain y value, let's say it's y of 1, then the y value of function f of x, this line, this graph, is greater by 2 compared to the graph of g of x. And so we have to find a point a where the x is equal to b, or which is also an integer, and where the graph of f of x, uh, this gives me where the point when x is equal to b and the subsequent y value of the graph f of x is greater by 2 compared to g of x. So what I mean is that points such as when x is equal to 2, you can see that the y values differ by 2 for f of x and g of x. But then we also have another point where this occurs, which is when actually we do not. And so there's only one point where this phenomena occurs. And so we can say that when x, which is also b, is equal to 2, we see that f of 2 is equal to, you can see, -1, and g of 2 is equal to -3. And so this satisfies our first relationship here, as in, and so we can say that f of b equals g of p plus 2 can be rewritten as f of 2 is equal to g of 2 plus 2. And we can plug in numerical values to prove this, because f of 2 was -1, g of 2 was -3, and if we add a plus 2, then the right side also becomes -1. And therefore, we can say that the b value is in fact equal to 2. But then the question isn't over yet. The question asks for finally the value of 2b. And so we have to multiply b by 2, which is simple, 2 times 2, which equals 4, which will be our final answer. And so does anybody have any questions regarding this one?
How is it equal to 4 exactly?
Because we found the b value here to be equal to 2 using our equations. And then the question asks for, if you look here, what is the value? Let me erase the top part. What is the value of 2b given the graphs? And therefore, because we know b is equal to 2, 2b is 2 times 2, which will equal to 4. Does that answer your question?
Okay, so like, do you do the line equation for the linear part? Like the g of x,
Mhm.
it's a linear equation. So like, do you like make the line equation and then find the x there? Is that how you found the x?
Ah, uh, that is a very good question, actually. So that would be the case. That would be true if we are given the actual equation for the lines itself, which we could find by analyzing the graph. However, we don't have to find the actual line equation itself. We just have to take a look at the visual graph itself and just find specific points for that are important to us in solving this question. So what I mean by that is, if we take a look back at the equation here, uh, the most important equation for this question is this part right here. We know that this shows that f of b, the y value of f of b, is greater than g of b by 2 because there is a plus 2 at the end. And so we have to find a point where this fx graph and the y value at a specific x point, x value, is higher than gx by a magnitude of 2. And so let's just take a couple points, for example. If we take a point where, let's say, x is equal to -5, then the intercept for the y value of f of x is roughly 0 because as you can see, if you uh, go all the way to the y-axis is equal to 0. And then at the same x value, the point for g of x will be here, which is around -6. And so the difference between the y values between these 2 points is 6. However, this is too big of a difference. We only want a difference of 2. And so we find a different point, and then we keep looking, we keep going to the right, and then until we find a part where the differences in the y values is equal to 2. And so if you look closely, you can see that when the x value is equal to -2, so when x is, excuse me, not -2, +2, you can see that these are the 2 points, and then the y value differences between the 2 points. You see f of x was -1 and g of x is -3. It will be 2. So this is the point of interest to us because it satisfies this first condition that we are given. And therefore, all we need is the b value, which is also the x value. And so we can see that our x value at that point was 2. And so we can say that b is equal to 2. And that's how we find this value for b. And then after we know this value, we can plug it in to 2b so that we get our final answer of 4. And so just once again to going back to your question, you do not have to directly find the line equation itself, like y equals a slope and the y-intercept. You don't have to find it because you're given a graph where you are able to find the values of specific points. And so you could find the line equation. However, you don't need it for this question. Uh, would that answer your question and any confusion you had?
It's answered the question. Thanks.
Yeah, no worries. And so we'll move on to our final challenge question of today. And so you can read through the solution once again. And so we find x values and y values of f of x and g of x that have a difference of 2. Like we did. Excuse me, this was an error. I thought that when x was equal to 3, there was a difference of 2. You could argue that there is, however, we're not able to find direct y values because they're not at a x and y axis intersection point. And so all we have to focus on is x equals 2. And then after we do that, we can say that b is equal to 2 and 2b equals 4. And so finally, moving on to our last challenge question of today, we have which statements are true based on the functions f of x and g of x. I think there was an error in the formatting on the xy plane. And so we can see that we have f of x on the top and g of x on the bottom. And then we have 3 statements. We'll go through them, each of them individually. And so the first statement says the function f of x and g of x will not have a point of intersection, meaning that the two graphs will not meet. Uh, and then if we go back a couple classes ago, we learned about parallel lines. Uh, and so when we have two parallel lines, then it means the slope's the same and they move in the same direction, which means that if they're on a xy plane, for example, at no value and at no point will those two slopes or those two lines touch each other because they're parallel. However, if there are two lines that are not parallel, either they are perpendicular or slightly different in slopes, then eventually they will meet at a intersection point, which is the case for this question's f of x and g of x. And so, if you see closely, the slopes are different. They are converging, you can say. They are coming to meet each other at a x value that is, let's say, for example, around here. And so at this point, the two lines will eventually meet each other. And therefore, you can say that statement one is in fact incorrect because statement one states that they won't meet. However, if we take a quick glance at the graph itself, we can see that eventually, yes, they will meet. And so we can cross out statement one and say that it is false. We'll take a look at statement two now. The product of y-intercepts for f of x and g of x is negative. And so all we have to find is the y-intercepts of the two equations. And so you don't need to find the linear equations themselves. You just have to find the point where for y-intercepts, excuse me, the x value is equal to 0. And so when x is 0, it's at this point. And so the y values for each, if we go up, we see that for f of x, the y-intercept is equal to positive 4. And then for g of x, the y-intercept is equal to, we'll take a close look here at this point where y is equal to negative 7. And so, knowing these two intercepts, the statement 2 says the products of these two is negative. And so if we take the product, 4 times negative 7 is negative 28. And so, yes, statement 2 is true because we get a product that is, in fact, a negative value. And so we can say that statement 2 is true, which leaves us to our final statement, statement 3, which says that the slope of function f of x is larger than that of g of x. And so by larger, you can mean if they're both positive, the greater number. However, if the two slopes are, if one is positive and one is negative, the positive one will be the greater one. And so just taking a quick look without any mathematical equations or solving anything, we can see that for f of x, the top line, the slope is sloping downwards. The y value is decreasing as x increases, which means that the slope of f of x is negative, while the slope of the graph g of x, you can see, is sloping upwards or increasing, which means that the slope is greater than 0. And so if the slope of g of x is positive, while the slope of f of x is negative, then automatically the slope value of the positive one will be larger because it is a positive number. And so you can solve it just using just mathematical, I guess, intuition and just uh, basic analyses of the slopes of the lines. Or if you want to be careful, which wouldn't be the case because I would it's fairly simple to understand this, but if you do want if the question if the statement, for example, asks for specific values of the slopes, then you would have to find the slopes themselves. And so let's practice that one more time. For f of x, if you look closely, would pick 2 points. One when the x is equal to 0, and the next one to the right where it touches. You can say that we'll pick this point because this point does cross the intersection here. And so if we do this, so we can draw a triangle like here. And so the 2 points, first one will be 0, comma. Actually, let's do the left point first. Left point will be -5, comma 6. And the right point will be 0, comma 4. And so m of the slope of the function f of x, we can write change in y, 6 minus 4. Actually, if it's change in y, it will be 4 minus 6 over 0 minus -5. You can do the other way around. You will still get the same answer. Uh, so this would equal to -2 over 5. And so we see that the slope of f of x is -2 over 5. We can do the same thing for the graph of g of x here. First point will be when x is equal to 0. The next point is when there's an intersection right here. And so we can use these 2 points to find for g of x. For g of x, the points are 0, comma -7. And then second point is 4, comma -6. And so the slope of the second equation is equal to, of g of x is equal to, change in y, -6 minus -7 over 4 minus 0, which is equal to 1 over 4. And automatically, because 1 over 4 is greater than -2 over 5, we can say that the slope of uh, the equation g of x is greater than the slope of the function f of x. And so we have two proofs for statement 3. And so we can say that uh, if we see here, the statement 3 says that the slope of function fx is larger than g of x. However, this is not true. The opposite is true. Gx is greater than fx. And so we can say that question 3 is also false. And so the only true statement for our final challenge question is statement 2. Does anybody have any questions for this one?
No.
Okay,
No.
if not, then this will be it for today's class, actually. And so the solution is here, as always. And so, yeah, once again, thank you again for joining today's class. And so today we cover most of concepts related to graphs, and basically any SAT question related to graphs will include one of the concepts talked about in today's class. So out of every, I guess, concept and classes we did until now, I would say graphs is actually very important, and it's one that is very important for solving questions well. And so I will be sending this one as well as last class's PPT to you as a PDF through email. So please wait for that. And so today's class was officially over and you're free to leave. Thank you so much, and I'll see you on Saturday for percentages.